Hey folks, welcome to Dr. Crispy's Shmoocon Swag Time Band. Somebody likes you. First, some t-shirts for smaller people. The t-shirt sizes are the t-shirt sizes. I can't wear this stuff. That's a moose oven mitt. This, I'm not chucking, this is going to hurt somebody. This is the Control-Alt-Hack game. It's white hat security hacking in the form of a card game. What member of the Shmoo group helped develop this?
You!
No. What?
Number 3. New question.
Insert correct answer.
Android apps.
Hey guys, all right, my name is Rahman, and today I'm going to talk about war stories. What kind of war stories? So there's, we're going to talk about some of the interesting things that have been happening in the world of Android application security over the past couple of years, some of the interesting vulnerabilities that were found, and we're going to talk about what those vulnerabilities were, how to avoid them, how to fix those issues, right? Most of those things are going to be pretty simple, but they're notorious. They're simple to fix, but unfortunately they're still there. So we're going to talk about this, and also at the end of the talk, I'm going to demo an app that I've written, which is kind of like a Hack Me style application. It's an Android application that hopefully you guys will have fun taking apart. So I feel this talk may be useful to people who are developing some apps for Android. One, if you're a pen tester who's looking to get into the field of Android security testing and you want to learn some more about Android security, this may be an interesting talk for you too. So, all right, just a quick caveat here in terms of what this talk is not about, because I kind of have to say this. No dramatic. We're not going to discuss any dramatic 0 days today. We're not going to talk about kernel exploitation or platform security. It's probably not going to be the talk. But like I said, hopefully you guys will have fun listening to this. So with this, we are starting. So, war stories. So these are some of the categories of different issues that we've been seeing. Not only us when we do our penetration tests, but also things that Mobile OWASP Top 10 has been talking about for quite a while. So these are some of the very common issues, and so. And so we thought, well, why don't we write an app, right? Why don't we write an app to try to cover some of those very common issues? And so the app that I'm going to demo at the end of the talk is going to be pretty accurately mapped to all of those categories, and there's going to be a topic for each one of those categories. This is a quick preview of what the app is going to look like, and we're going to start with logging. So I wanted to kind of start with this because this is one of the very easy things to, I don't want to say exploit necessarily, but I would say take advantage of rather, because to get to a log that an Android application is throwing to the logcat is actually relatively easy, right? I mean, to do that, the only thing you have to do if you're let's say a hacker and you have the phone is you just hook it up with a USB cable or some apps, and we're going to get to this in a minute, could also read logs a little while ago. And so the point of this is that there is a pretty high probability of some sensitive information that's being put out to the log. So if you think that stuff like usernames, passwords, IDs, authentication tokens, stuff like that doesn't get logged, well, it does. And so here's a couple examples. Passwords that are being revealed in the Android log, or Facebook authentication tokens, auth tokens, or last 4 digits of a credit card number being output, even more passwords. So the thing is, like I said, this is one of the very old issues, and the earlier samples of malware, they would basically request a read log permission, and requesting the read log permission would give them the capability to read other apps logs. So, all right, should I start with this? No, I'll probably keep this until the end. All right. So, all right, I can start making cocktails here. Anyway, so before Android 4.1, accessing your application logs was actually pretty easy, because all that a malicious app had to do was to request read logs permission. If you as a user granted that permission, now that app could go out and grab those logs. Now, from Android 4.1 and up, it made it a little bit more difficult, because now, even though you can request the read logs permission, you're really not going to get it. So the system is not going to grant that permission. So that gives you some degree of protection, but at the same time, Android 4.1 Plus is at a limited distribution in the marketplace right now. So it's still important to look for the places in your code, if you're a developer, or in the code that you're reviewing as a pen tester, for log entries, because there's a lot of juicy stuff in there. So, like, as a developer, it's probably going to be hard to find those things, because they tend to hide, especially if you have a pretty big application. But at the same time, a lot of interesting stuff is in there. So yeah, this is basically it. Make sure that nothing sensitive gets dumped to a log. Oh, and one more point. I guess if a malicious application is running as root, then all of those protections don't really work anymore. So it's going to be able to read your logs no matter what. All right. So moving on to file permissions. So when I talk about file permissions, what I mean most of the time is I want to talk about world writable and world readable files. So even though this may not happen as often as some other vulnerabilities that we're seeing, when it does happen, the consequences tend to be pretty destructive and pretty bad. And so I wanted to bring in an example of Lookout Security, which is a security product, Android security product, a vulnerability in which was discovered by Team Joxo, that John Aberheide and Zach Lanier, as well as Tevis Romandi, who independently discovered the vulnerability as well. And so what the vulnerability was that the application decided that it can place its system database and a configuration file inside its app directory, except make it world readable and writable. So any app could go out and update those two files. What ended up happening, and this is an exploit that Tevis Romandi ended up writing, he ended up updating those files to have them picked up by the Lookout security application, and that resulted in the administrative actions being carried out on behalf of a malicious app by the Lookout security product. So, Android tries pretty hard, well, not Android, like the whole development environment tries pretty hard to prevent you from setting like relaxed permissions on application files, right? Like Eclipse, for example, throws a ton of warnings saying that, hey, are you really sure? Are you absolutely sure that you want to set a world writable permission on the file? So, most of the time I would recommend, again, if you're a pen tester to your clients, don't use world writable stuff. There's really no reason to do that. And also, a special case is SD card permissions. So SD card being, being most of the time formatted as a VFAT file system, there's really the lack of concept of file ownership. And because there's no file ownership, anyone can access everything. So don't put secrets onto an SD card. That may not be such a good idea because the whole world is going to be able to read it. Oh, and just as a little, I guess, caveat here is like all of the vulnerabilities that I'm talking about have already been patched. So like I said, no 0 days today. All right, moving on to content provider. So why would you need a content provider? You need it to share, right? But when you share, most of the time you want to share only with select people, select apps, select entities, right? And basically what a content provider is on Android, it's like a structured storage mechanism that for all intents and purposes acts as a database, right? And so, so you can use this to share data with the outside world, with the app. So one example is, let's say you have an email program that reads, you can read emails in the program, and you can also open up attachments. Like let's say there's an image, and if you want to view an image with a if you want to view an image with a gallery viewer, then gallery viewer may choose to access the email client's content provider to get the data. So one of the problems that are there with content providers, or could be there, is when it starts to leak, which means that other apps can all of a sudden start accessing those providers. And here, another war story is the Dropbox. And in 2011, Tyrone Erasmus found a vulnerability where you could access the content provider that was advertised, that was shared out by the Dropbox application, and you could read the entire database. And as a result of that, like being a malicious application, you could just upload users' data for public access to anyone. And so if you look at the little snippet of code, you'll see that the provider tag, first of all, it doesn't list any permissions whatsoever. And also the grant URI permission tag has a path prefix attribute set to /. So that effectively makes the whole database available for others to look at. So that's a bit of a problem. So make sure that when you share a content provider, you only share it with granular permissions. So you specify who exactly you're sharing it with. It may be a good idea to use signature level permissions. So with signature level permissions, what happens is only the applications that have been signed by the same key as your application can now access your resource or content provider in this case. So one other point that I have here on the slide that I wanted to talk about separately is the parameterized methods for queries. Since content provider implements several database methods, it's normally a good idea to just use the methods that are provided by the Google platform and not try to write your own code in order to not open yourself up for SQL injection. Because SQL injection can happen anywhere. It doesn't have to be a web app. It can also happen locally inside your application if your input is not properly validated. So this little diagram is actually taken from the Android developers website, from the Google reference, that shows how the query arguments, and the query arguments is used to basically pull stuff from the content provider, how it maps to the SQL statements, or just SQL operators and keywords. And so most of the time, what you need to do with SQL, you can you could also do with content provider methods such as the query method. So use that. All right. So URIs. The URI is effectively a scheme that lets you, invoke an application to handle a certain type of resource, right? So if you have an HTTP : / that's a URI scheme that may trigger a browser. If you have a my_app : / blah blah blah, that may trigger the my_app application. So you would normally declare the URI scheme in the manifest under the data tag. And the example that I wanted to talk about here, a pretty destructive one, or destructive in a funny way, I guess, is an example that Colin Mulliner presented, I believe it was NinjaCon in 2011. And so this was a case where it was an NFC token, an NFC tag that was presented to a phone, and then the Android system would parse out the URI out of the data encoded in the tag, and then the URI that was extracted was passed over to the Foursquare app because it was registered as the handler for that URI. And well, guess what happened? So the the Foursquare application just goes ahead and makes an authenticated call to the server, completely trusting the data that came from the tag. So why is this a problem? Well, so what happened was, let's say that you wanted to check in at Times Square. And by the way, like all the screenshots here, came from Colin's presentation, so I'm crediting him for this. So let's say that you want to check in at Times Square. What happens in the Foursquare application in the backend is it gets associated with a certain name of the venue name, right? But what does not happen is that the name is not associated with the venue ID. So, for example, if an attacker were to create a little fake NFC transponder or fake NFC tag, I'm sorry, that would have a venue name that was Times Square, which is where you think you are, but the venue ID that was different, you end up checking in someplace else in Chippendales. So, well, I guess everyone sees like potential issues with that, especially if you do this during work hours. So, some other potential scenarios that could happen here is effectively what's cross-site request forgery, right? If the application just blindly passes data that's been received from the tag, it gets it over to the server. Well, if you have some more sensitive functionality, such as add a follower or add a friend, things like that, you end up making all of those requests in the context of an authenticated session, and as a result, you may end up like adding a follower that you didn't really want to follow. So like all sorts of stalking issues come up here. So. The moral of the story is, this is a really old thing, and I'm sure you guys have heard this multiple times already. But this is another example why you shouldn't trust anything that comes from outside your application, even if it's like an NFC interface that you may think it may be more secure for whatever reason. Truth of the matter is, it may not be. Oh. So another interesting vulnerability here is what happens when we take a URI handler and we somehow combine this with a web view. So this may not make sense right now, but hopefully it will in a few minutes. So what's a web view? Essentially, it's like a simple class, a simple mechanism to view web-based content in your application. Even though it's pretty simple, it actually supports some pretty interesting functionality. It supports a bit more than just static pages. For example, JavaScript. Other client-side stuff as well, but JavaScript is an example that I want to talk about today. So a JavaScript interface, you can add the capability for your web view to interact with your application. So even though by default JavaScript is disabled, you can deliberately enable it. And well, there could be potentially issues with that as well. And you really have to ask yourself a question. Do you need that? Do you need JavaScript? What happens if the JavaScript that I'm putting in my web view has an interface in my application that it can access? And that interface supports some sensitive functionality. Well, what can happen is, let's say I register a URI handler. It's called blah. So everything that starts with blah is going to be handled by my app. So then I take whatever data came from the URI, I stick that into a JavaScript-enabled web view. So now there's stuff, JavaScript client-side stuff running in the web view, but then there's an interface, a JavaScript interface that's exposed that my application can now talk back, that the JavaScript can talk back to the application through. So if I post a link on any page, right, that contains this URI handler, and I specify a malicious payload, it will effectively end up invoking some potentially destructive functionality on the application because it can talk to it through the JavaScript interface. So here's a real life example here. This is the manifest where you have a data scheme, blah, right? And then this is where stuff that got into the application from the URI gets stuck into the web view. So this is a link that I can put on my website so that it would be all right. It is better? All right. Whom have I been talking to all this time? All right. Anyway, so yeah, when you take stuff that came from the URI and it got into the web view, now if I advertise and add a JavaScript interface inside my application, and it eventually makes it into the web view, well, I can invoke code through the JavaScript interface functionality and execute code within the application. This is the code that's being run within the app. So stuff goes from the web into the application. Application takes parses the URI, puts it to the web view runs, and then calls stuff back on the application on the JavaScript interface. So possible problems here, you can end up just giving up control of your application to a malicious entity, to a bad guy who ends up posting a link on the web page, or alter your data. So there's a whole bunch of different bad things that can come out of this. So if you can, a couple of things that I would recommend here. First, make sure that you limit the domains that you can load through the web view. There's really no reason for your web view to load stuff other than from places that you would expect to load stuff from. So if you have some server backend that serves HTTP content, you can specify that as one of the restrictions. And also be very careful with the JavaScript interfaces, because you don't want to advertise functionality that may be invoked by code that comes in through the web view in a malicious fashion. All right. Now let's talk about intent. So I'm hoping most of you know that with intent, you're essentially like passing kind of like event-based messages between different applications, and even though stuff happens locally, the same input validation paradigm, believe it or not, applies here as well. So here you should also make sure that you don't trust stuff in the intent blindly and require permissions every time you're handling intents. The example here is Google Wallet, and this is something that our Intrepidus guys found in April of 2012, where a malicious application could enable remote logging. I take it back, not remote logging. It could enable logging of last 4 digits of a credit card through throwing an intent. And the application, the Google Wallet, did not verify the sender of that intent. And so this little snippet of code here shows, well, this is basically a piece of the exploit code. So what happens here is an intent gets declared by, let's say, our application, written by Intrepidus. We set the action to blah, 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 change log priority level, and that's the action that Google Wallet will have an intent filter for. Then we add a little extra field to turn on verbose logging, and then we just kind of blast it out. And what happens is, well, of course, the application starts dumping the parts of the credit card number. So this is what the this is what the receiver looked back then, right? So anyone can just send stuff to it because it will be intercepted by the intent filter. It will be caught by the intent filter, and the receiver, the broadcast receiver, would act on that. This could have probably fixed it, because once you don't export your intent, now you can be sure that only the components of your application can access can send stuff to the receiver. Another way to expose this intent, but only limited to certain entities that should be calling stuff on it, would be to require permissions. So when you request a permission, and especially if that's again a signature-based permission, right? You're ensuring that whoever sends an intent to your receiver or to your application has the same signature as your app. I mean, you don't have to use signature permissions, but I'm just saying that because signature permissions are normally transparent to the users. They don't have to actually go and click and say, "Hey, it's fine. I accept your app. I accept that your app needs this permission." So because of this, because of the fact that it's transparent, it may make for a better user experience when you do it this way. So. Couple of things to watch out for. So if there is an intent filter, the activity instantly becomes exported. So you have to make sure that if you don't mean to export your activity or only have it accessible by your internal components, you set the exported attribute to false. And like I said, for sensitive actions, definitely make sure that whoever calls into your app has the proper permission level. And also, when you invoke activities, big granular, and when I say big granular, basically require that the activity is invoked by the class name if possible. Now, I understand this may not be possible in all times because sometimes you just don't know what the class name is going to be if you're calling into a different application. That said, think about a scenario where your intent that you're throwing matches several intent filters. And so if it matches several intent filters, this could potentially bring about a security issue, because what happens if someone who's trying to intercept my intent ends up being malicious? And I, as a user, say, oh, all right, I'm going to open this link with either Google Maps or G00 Google Maps, and I end up clicking on the wrong thing, and the intent ends up going to the wrong place. And this kind of goes back to the prior recommendation that I mentioned about not putting sensitive stuff in intents in the first place. All right. Encryption issues over the network. We're going to talk about a couple things here. First of all, I think it's pretty safe to assume right now that, since most of you are probably pen testers, I'm guessing, intercepting stuff locally is pretty easy, right? So man-in-the-middling stuff if you're local is relatively easy. Not so much when you sit on a different machine, but if you're local, that's easy. And when developers do something like they use self-signed certificates in their production code, well, guess what happens? All right, so you're essentially getting rid of the whole CA validation modal and certificate authorities, because any certificate is now a good certificate. I can put whatever I want as a man in the middle and see the traffic. When would that happen? If you override the trust store, the default trust manager in Java, that's what's going to happen. By the way, it's difficult. Overriding that manager is difficult, but we've seen it done. The thing is, like I said, like with some other items, Eclipse makes it difficult. Java complains a lot about this. So don't override default trust manager. So how does SSL validation work on Android? So most of the time, the SSL validation would be done by the Android system. So it would look in the trusted certificate authority store, right? And it would say, hey, the certificate that I'm seeing from a server, is that good? Can I trust it? Can I not trust it? And then it makes a decision based on that. So if, as an attacker, you end up pushing your certificate into the trust store, you can now see the traffic. Well, before Android 4.0, you could use you could use the KSource BKS trust store, but you had to be rooted to push your certificate, your signing certificate into that store. With Android 4.0, things have become a lot easier. You can now use user certs, which means that all you have to do is just put your signing cert on an SD card and just import it. And that's it. Now your system trusts any certificate that it sees. So what do you do about this? As a developer, it may be a good idea to use certificate pinning. With certificate pinning, what you would essentially do, you would pin the public key of your server to the domain name, to your domain name. So every time that your application tries to reach out to a server, it would know the exact certificate that it should be seeing. Another way to do certificate pinning is, instead of pushing the exact certificate hash, the hash of the public key into the code, you can also have the signing certificate of the certificate authority that only you can sign your certs with. And that way, you can check if the server cert that you're connecting to, if its cert has been signed by the known CA. Now you know that in your code you're pinning it to a certain CA, and now that you know that it can be trusted. So in a way, you're kind of removing the normal CA validation out of the, you're removing it from the picture completely. So is pinning a good idea? Definitely. Is that a silver bullet? Probably not. There are ways to bypass those. Like ISAC Partners, Android SSL bypass tool has been written specifically to bypass pinning on Android applications. But the thing is, it's not an app that's like, very, very easy to kind of break out and use. It definitely makes the hacker's job of breaking the application a lot harder. So I would say that it's still a good idea to add another degree of complexity to hacker's job. And by the way, if you guys are interested in reading more about certificate pinning, I would suggest reading the Moxie Marlinspike's blog. He's got a great entry on pinning, so I would definitely recommend doing that. All right, now we've talked about encryption that was done locally. Let's talk about encryption. Encryption over the network. Let's talk about encryption or encryption that's done locally. So I've seen this take one of three common forms. Number one, hard-coded keys. All right. Weak encryption algorithm. People still use weak ciphers and all that stuff, or maybe some stronger encryption algorithm, but those where their strengths are completely defeated by the fact that they're used improperly, and security decisions are made locally and can be completely bypassed. So one example that I have is an app that has an authentication token that it presents to the server, and the token is a SHA-1 hash that's based on a phone number. Let's think about this. SHA-1 hash based on the phone number. SHA-1 hash, all right, reasonably secure, that's fine, but it's something that we control locally. So once we know that the phone number is what's used to generate the SHA-1 hash, the question is, well, can we maybe SHA-1 hash other phone numbers and all of a sudden become different users of the application? So this is actually exactly what happened. I mean, it was a pretty massive fail. So
Show that again.
I do that on request. Sure. Here you go. This guy may not know a lot about encryption, though. All right. All right. So, to kind of recap the whole encryption thing here, a few suggestions. So, don't abuse SSL. If there's a trust manager, use it as intended. Don't try to get around it, even in the development code. Augment your stuff by pinning certificates. You can use other stuff. You can use, mutual authentication is also a good idea to use, so that you're now presenting client cert to the server, so that the server would know who's connecting to it. Also check the local signature of an application to make sure that your application hasn't been messed with. Maybe a little extra bit of work, but still worth it. And in terms of protecting your application from maybe remote man-in-the-middling, it would be, you can't really force traffic out of a specific interface on Android, as far as I know, but you can certainly prefer one interface over another. And so what I would do is, in my code, I would assume that everything goes over Wi-Fi that can be controlled by an attacker, and prefer to send traffic out of the cell network. All right, so here is some technical suggestions. Remove debugging code, secure your app's resources, meaning make sure that your file permissions are set properly. You can use certificate pinning. Definitely use obfuscators. Make sure that you use ProGuard. It's free. Android lets you use that for everything that you write. It also strips unused code, which is a good idea anyway. But most of the time, try to really look at the big picture, and recommend to others to look at the big picture. So try to think like a hacker, and what it means is, look at your application from a very high level perspective. Try to enumerate the risks. Maybe there are certain things that you did not intend to happen, and they would happen anyway, right? So there could be risks to your data. There could be risks to the infrastructure, and so these are some of the things that you need to keep in mind as you're pulling together your app. Next step: identify the attack surface. And so I think what that cat was doing there was trying to identify the attack surface with a turtle. So think about, what sensitive info is transmitted by your app, what's stored, are you maybe using some insecure libraries? And so all of these things together, they really help create a more secure application from the get-go, as opposed to trying to patch it later. And finally, challenge your assumptions about security. I gave you an NFC example, right, where an assumption was made or possibly made that something that came from an NFC interface is somehow more secure. May not necessarily be the case, because you may think that attacker may not have access to the hardware required to write to a tag or deal with some other technology, but the truth of the matter is it's actually much more possible that you may think it is. So just keep that in mind and challenge your own assumptions. Yeah, all right, and finally, it's important to understand how Android reversing works. So there is a lot of conversations about how secure or insecure Android platform is. The truth is that the oversight on what apps get pushed into the market may not be as rigorous as with some other platforms, and I'm going to let you guess which platforms I'm talking about. So you can pull apps from a phone, you can recompile them, you can patch them, you can recompile them pretty easily. There's a ton of tools available. You can change the code because the apps are written in Java. So there's a lot of things that you can do with an app. So the most important thing is you really should know how the app could be broken. And with this, I'm going to move to the IG Learner app demo. So this is going to be a demo of the IG Learner app, and it's like a CTF style app. CTF is the, for those who don't know, capture the flag type application. It's a bit easier than a regular CTF, but it's like a lesson-based, like a level-based type of thing where you have a whole bunch of challenges, and you're supposed to solve those challenges. The QR code here links to the market. I'm telling you, it's totally legit to go ahead and download that. Take my word for it. I really like watching people's reactions, to take my word for it. Okay, and we also have the code up on GitHub for this. There's a walkthrough. It's currently being finalized, so please check back on intrepidusgroup.com's inside blog. And also, I definitely wanted to mention two more things. Shouts out to Jack Manino, who kind of inspired, whose GoDroid project kind of inspired me to write this. Definitely check out that project. It's awesome. Highly recommend it. And the entire mobile OWASP top 10. There are quite a few differences between this and GoDroid, and you'll see them. But I would say that definitely check out Jack Manino's OWASP top 10 project and the GoDroid application. All right, and by the way, you don't really need anything besides the APK to run this. So, all right, demo. All right, so I'm going to move this over. All right, so what happens here is this is the listing of lessons. So we have lesson for every topic there. You can see the instructions if you want to read the instructions. And then you can, all right, close the instructions. In hindsight, I probably should have made the video go a little bit faster. Apologies. So you can try to type in some garbage in there. And so, by the way, like right now, I'm burning one of the lessons. This is like the most trivial lesson of the application. It's really simple, really easy. But I just want to kind of make sure that you get the flavor of what this is. So this dumped a whole bunch of debugging output to the Logcat console, and there's a secret code that's lurking in there somewhere. And I'm going to show you how this works. All right, so that's the code right there. So the next step is going to be, I'm going to punch this code into my app. A spoiler, I'm going to punch in the correct code here. All right. And so, like I said, an important thing that I want to mention here is that this is a really trivial lesson, and the other lessons are quite a bit harder, but I think they kind of go increasingly harder as you progress through the exercise. And so this is just a quick overview of some of the tools that you may want to use as you're taking apart the application if you want to. So Dextrajar will give you, will translate the APK, the installation file, to a readable Java code. The problem with Java code, even though you can read it and understand the logic of the application a lot easier than otherwise, you can't really recompile it back into an application. Again, this is something that you would normally use to just try to understand the logic of the app and then just putting this into a Java decompiler and running this inside the JDGUI tool. So here, this is, let's see, like this is my logging garbage method. You can see that the code is not obfuscated. It was actually not obfuscated on purpose. And this is the Virtuosten Studio tool that I use to look at the Smalley code. And Smalley code is effectively the instructions that run in the Dalvik VM, and the smaller representation of an APK is something that you would use to actually patch the code, make changes to it, and recompile it back. So I'm going to kill the video a little early here because just to save some time, but I'm going to tell you that with this tool, which is, by the way, a great tool, Virtuosten Studio is its name, what you can do is you can just recompile it and push it back at the click of a button, which is pretty simple. And you can just take my word for it again, that it's actually going to push back and execute just fine. So I know that I'm running a little bit short on time, so I'm just going to close this up right here. And say that here we're done. If you still want to get the app, download the app. The QR code is right there. So thanks very much for coming out. Thanks very much for listening to me. And if you have any questions, I think, do you have time for questions? I would gladly take some.
You see more apps that are out there in the wild being programmed more and safety codes, and are there any known methods against reversing the code or
So the question was whether there were any methods for reversing ProGuard obfuscation, and if apps were using ProGuard. So, part of the problem with obfuscation is that sometimes you may not know what the program was obfuscated with. ProGuard, I would say, like knowing the transition between the source code and the, knowing about the source code, a lot of people do use ProGuard. But yeah, that's sometimes a little bit difficult to figure out what it was obfuscated with. And then in terms of anti-obfuscation, you can have some indirect methods of trying to figure out how things were obfuscated. But these are really, like I said, the key word here is indirect method, right? You can deduce by, let's say, following the class hierarchy to say, hey, like this seems to inherit from this class and this seems to inherit from this class. This is what's probably happening. But there's no tool that I'm aware of that would just take an obfuscated APK and turn that into a non-obfuscated code. If that answers the question. Cool. Anything else? Anyone else?
Thanks, guys. Oh, actually.